So NI, as a platform company, is able to address a number of different challenges we see both in the educational space, that's teaching and research, as well as from the industrial space as well. So as we're looking at that, I think NI is certainly providing scientists, researchers, and innovators what they need to be successful across those broad set of areas. But there are some mega trends that we're seeing that are having some significant changes in the market. I think with automation and what's coming with automation, which is manifesting itself in IoT, in 5G, in the autonomous vehicle, we see these trends as having an incredible impact on the industrial side, and that'll happen also in areas like aerospace and semiconductor as well. So I think as we look at those mega trends and the impact that they're going to have on the industrial side, we see obviously a downstream effect on what's needed from education as well. And so what we're seeing in the educational space is the ability to apply things like mechatronics, things like IoT, things like communication to effectively prepare students for areas like 5G, like autonomous vehicles, robotics, as well as some of those other key areas. I think on the research side, we see the bridging between both of those worlds, where a lot of the research space is happening in preparation for some of these mega trends that we'll see in industry, but also making that connection back to students to make sure that they're going to be successful when it comes to being researchers or going into employment as well. So when we look at the broad market, I think employability is a key theme that many educational specialists are obviously speaking about. We see increasingly a need for students to come out of their engineering program essentially ready from day one to make some pretty big impact in their own company if they're doing startups, or in larger multinational companies as well. So I think from that perspective, whether we're here in the US or in Canada, or we're globally looking at what the needs are from industry, I think employability and those skills associated with it are going to be incredibly important. I think we've seen some really interesting data come out of folks like the ASEE in their TUEE study, where they've actually spoke about some of the key elements around teamwork, about understanding engineering systems, about being able to address complex challenges effectively. And we've looked at some of those skills being incredibly important when it comes to integrating them into curriculum as well. So for NI, we've been partnering very closely with educators around the world to make sure we understand obviously some of their key success metrics, such as student engagement and retention, but also making sure we're developing the right skill sets in those students as well. One of my favorite examples is the University of Virginia and some of the work we've done with Harry Powell, where we actively engaged with Dr. Powell and with the institution to develop a new approach to teaching electronics. He used a studio learning format where he's now teaching electronics over 3 different courses and building consecutive skill sets between each one of those courses through design work. Ultimately, what he's seeing is students are getting far more engaged because they understand how every one of those topics are very interconnected, but also understanding how those skills will obviously be used in design work as they go into industry as well. And so if we look at that broad set of area, whether it be the University of Virginia or the University of Manchester or the University of Leeds, we've really spent a lot of time in really partnering with educators to make sure we understand how design work, how student-centric projects are really going to change the way students are learning, and really building some of those soft skills in concert with the technical skills as well. And I think ultimately for us, we're seeing that come from increases of project-based learning and active learning within the curriculum throughout programs around the world. So National Instruments was founded by Dr. James Truchard, who himself was a professor at the University of Texas at Austin. And it was in those interactions that Dr. T, as we affectionately call him, found that students had the ability to be incredibly innovative, but also how, as they got into research, there was such an incredible impact we could have in the world at large by what was happening within institutions. So really from day one, Dr. Truchard often would state that it all starts in academic, that there's an importance for companies to partner with institutions to ensure that we're supporting the development of those future innovators in those formative first 2 to 3 years inside of their engineering program, as well as making sure that we're supporting those researchers once they start working on those complex, ambitious types of projects. So from NI, really in our DNA, it really started from day one for us to be able to effectively partner with academic institutions and make sure we're providing the foundation for them to be successful. Because ultimately, as those individuals come out of academic programs, they're going to make an impact. He or she will definitely end up at some of these large companies doing those ambitious projects. They will be the ones that are tackling some of the big societal challenges that we face globally as well. And so for us, obviously, that investment into academic and that partnership has been very important for the 30, 40 years of National Instruments. So when we look at the large megatrends like 5G, IoT, autonomous vehicles, obviously it creates some challenges, but some incredible opportunities for students and researchers to work on some really ambitious projects. I think that the challenges associated with the educational space, with the research space, are slightly different. So I think on the educational space, one of the key challenges is that we need to ensure that we're building the right level of knowledge in a broad set of areas. So that's both at the foundational topics, things like electronics, things like measurements, things like digital design, but then also being able to take those up a level and really learn about systems as well. So looking at that rich tapestry which builds upon those foundational topics into subsystems that are really going to be used to build those more ambitious projects. And so if you look at something like an autonomous vehicle, for example, we need to make sure that a student's going to learn communications, needs to understand mechatronics, is going to understand embedded design. And so combining those into really strong foundational elements in the educational program is going to be a critical challenge. Now, the opportunity with all of this, particularly in the undergraduate space, is that we're going to have students working on some of the most ambitious, exciting projects we've seen in a very long time. And so as we look at how to not only retain, but also attract the best and brightest students, I really see that tying a lot of what was happening in those megatrends into the curriculum is really going to excite and attract some of the best students possible to really tackle those types of opportunities. Now, on the research side, I think one of the key things that we're seeing is that as we go into these very complex systems, we really need to provide researchers with the right foundational tools to be successful as well. So if you're working on a system, it really helps to be able to be provided with the right starting point with an off-the-shelf solution that integrates a lot of the common I/O, a lot of the common processing power. So what the researcher is really focusing on is how he or she can deliver on the research outcomes that they're working on. If we think of something like, again, the autonomous vehicle, we're dealing with physical measurements of sensors. We're dealing with often having to understand the electric vehicle drivetrain. We're having to deal with communication systems and IoT. If we think about all of those disparate parts, we're going to have to combine them into one system at some point. I think the faster and easier we can provide elements of that to a researcher, the faster that they can actually look into the really ambitious, exciting areas where those things can get applied. I think we're going to see that in 5G, where the inherent complexities that we're seeing in delivering that type of communication protocol will really require us to have a faster way for researchers to iterate and to prototype. And again, IoT, semiconductor, aerospace, all of those really exciting areas that we see researchers working in today, I think we'll need that type of same platform approach to be successful. I think as we look at engineering education over a longer time span, really since from when it began to the 1950s, the 1990s and onwards, I think a lot of what happened prior to the 1990s was about theory, it was about practice, it was about the science of engineering. I think particularly in the last 20 to 30 years, what we've really seen is a movement more and more towards being able to support students to get past the theory, but really be able to apply what they're learning in the classroom to what they're going to be able to do when they're graduating engineers. So I think the concepts like project-based learning and active learning are going to be incredibly important as a part of this kind of future trend. I think a lot of what National Instruments has done for the past 10 years about the concept of do engineering, that ability to get the right hands-on experience for students into the classroom has been really aligned with that direction. I think now what we're going to continue to see is how more design work, how more creativity, how more student-centric projects can be integrated into the curriculum, so that when that one student is in that laboratory, he or she are building upon the foundational knowledge of areas like electronics or communications. But at the end of that, they're also going to get the design work and teamwork that's going to really help them build kind of that next level of knowledge. I think that element of teamwork is also a really important thing. I think back to my experience in the laboratory, and I worked with one partner often. I think as we move forward, those teams have to be larger because they really need to reproduce some of the elements that the students are going to deal with when they're actually out there as practicing engineers. And I think those multidisciplinary teams, those opportunities to learn from colleagues, but maybe colleagues not even from your own department, maybe from mechanical, maybe from business. I think those interactions are going to be extremely important. And I think the trends associated with active learning and project-based learning to help make that a reality are incredibly important trends, and frankly, exciting trends. I think that's where professors and faculty are really going to be able to make a change in the experience for the students. I think as we've seen in many examples around the world, there's an actual output of those, which is the engagement, the enriching experiences that students will get out of those types of experiments and out of those types of practical experiences. And I think that's what's really exciting about this next generation of educators and the next generation of students that are going to come out of these programs.